All right, we're going to continue building the code for our maze solver. So far we've got, we built our circuits. We've got 2 servos to control the maze, got our joystick, and now, and we have our physical actual assembly that we're programming that looks like this guy right here, okay? And so now our next step is we have control basically of the servo motors with the joysticks, but now we need to really like hone in on getting basically like more consistent and better control over it. Not consistent, but more control. So obviously like it's going basically a whole range of motion, 180 degrees. Probably the servos aren't perfectly centered. Those are the things that we need to fix right now. And so we have these values here for the servo center. And we'll also come up with 2 more values that are going to basically represent like the center of our inputs. And so we'll also say const int x input center. And for now, we got 0 to 1023. And so half of that is going to be 512 for now. And so we have our x input center and our y input center. And we're going to use these to kind of tune our joysticks as well. Okay, and so these are going to be we're going to be tweaking these to kind of get ourselves perfectly in tune so it's working the way that we want it to. All right, and so the next thing we're going to do is we're going to actually write a function that's going to basically give us kind of map our servo to the position that we want. Okay, let's actually add one more here. So I'm going to say const int x max offset, and we'll set this to be like 30 for now, and this is something you can figure out later. Y max offset. Okay, so from here let's write a function called map servo. And it's going to give us back like a position for our servo. Okay, and I've got my notes right here, so I'm going to reference them. So we have int map servo, and what we're going to do here is we're going to basically pass in the value. So we'll say int servo center. So we're going to pass in what our center point for our servo is. Okay, so like it's going to start at 90 degrees. So we're assuming we're starting at 90, but this will allow us to kind of also account for if it's not perfectly centered, like if it's at 92 or 80 or something like that. And then we're going to say int input. And then what we'll do is we're going to say int input center, int direction, and int max offset. Okay? And basically what we're accounting for is this. First of all, like we might have our direction swapped on the joystick versus our servo, so we might need to flip that so it goes the way we expect it to. This is that input center of the from our joystick that we'll tune to make our joystick work. This is the actual input that we're getting, and we're getting a value. Our output will be basically telling us what the angle is relative to, or based on rather, our servo center, and constraining it to this max offset. So like if based on the joystick position it's telling us to go to 1023 or to like 180 degrees, but our max offset is like 20, then it won't give us anything higher than like 110 degrees. Okay, so first what we're going to do is we're going to find the difference between the input and the input center. Okay, so int, so we're going to say sensor diff equals input minus input center. Okay, and so this is going to tell us basically what the difference is between these 2 values, and so how far we are off from the center. Okay, and then from here we're going to multiply this sensor diff times equals, we're going to multiply this by our direction. Okay, and so that if we want to invert it, it will flip it for us. Okay, and then from there we're going to actually get a map value. So we're going to say int mapped angle equals We'll use the map function. And so we're going to use that sensor diff here. Sensor diff. Actually, no. Sorry, we're going to use, yes, sensor diff. And then we're going to say negative input center to 1023 minus input center. And those are the ranges of our output. Let me think about this. Negative input center. I'm going to go negative max offset to max offset. Okay, so let's say our max offset is 20 degrees. So then this will be, we're going to map between negative 20 and 20. Okay, our sensor difference is how far off from the center. So if like our input center was like 512, say minus or rather input center was 512, so then this would be like our sensor difference would be like, so let's say we're at like 600, so it'd be 600 minus 512, so this would be like maybe like 88. Okay, so we might be putting in that value of 88, and then our input center, or negative input center, would be just the negative 512, and then 1023 minus input center would be 512, right? Or we'll say, I mean, 511. Okay. And so what it's going to do is, it's going to say, my difference here, I'm going to see where it is between negative 512 and 511, and I'm going to map it to this range here, negative 20 and 20. And so let's say instead our input center, I mean, as the input center changes, right, as we get further away to one side, then these values change based to account for that. And so let's say if this was, if this value was 500, then we would be getting out an angle of 20. Whereas if this value was negative 500, we'd be getting out a value of an output of negative 20. Okay, and so what this does is it's taking the difference between the center of our sensor and the actual current input, and it's mapping that between the whole range of possible inputs and these two angles that we want. Now, given that this input might not be perfectly centered, we do have to do some constraints. And so the first thing we're going to do is we're going to say get our servo position, and we're going to basically account for our servo center now using that mapped angle. So it's going to be servo center plus that mapped angle. So in this case, it'd be like that value between negative 20 and 20. And so it might be like 90 plus negative 20, so it might get 70, or 90 plus 110 and give us, or 20 and give us 110. However, it's not going to be perfect, and so we need to also account for the basically the cases where this will give us values outside of these. So if the sensor difference is less than this or greater than this, then we'll actually get offsets that are outside of these, and so we have to account for that using constrain. And so we're going to say servo position equals constrain, and this is a function, an Arduino function, that will return this value constrained between 2 points. And so here we're going to constrain servo position to be between servo center minus max offset and servo center plus max offset. And so what this does is this will give us a value that basically this will ensure that our value is between the center and those two kind of offsets. So like in this case, if we say our center is 90 and we have an offset of 30, then it's going to be between 60 and 120. And that's what this function does. But we have to also constrain it one more time. Servo position equals constrain, because we could also have the case where the servo position, based on the inputs we give, could actually be outside of the bounds of the servo. So I want to make sure we don't get a value that's less than 0 or greater than 180. Okay, so we'll make some notes here. So we're going to constrain between 0 to 180, constrain to plus minus offset center, and this is going to add offset to servo center. Here what we're doing is we are mapping input between max servo offset account for correction. Okay, and then finally the last thing we'll do here is we're going to now return our servo position. Okay, so there's a lot there, and now we're going to come down here, actually go up, and we're going to call this map servo function right here. Okay, so we're going to say x axis center. Let's see what we have, x axis or x servo center, and then our input will be the x axis value, and then x input center. Oops. X input center. We'll set the direction to 1 to start, and then our max offset will be x max offset. Okay, and so this function gives us that position in a way that basically like will kind of tune or kind of constrain it in a way so we're not getting that full 180 degrees. So we'll change these to be the y-axis values. And so now, and let's actually go like this as well. We'll say const int y direction equals 1, const int x direction equals -1. So now we have all these values here together, and I'm actually going to move them around. So let's put all the y ones together and the x ones together. And so we can use this to kind of tune our setup here. Okay, so y max offset, and then y direction. So now that we have these ways that we can tune each of our axes, okay? And these are just the inputs up there. So tune x axis, tune y axis. Okay, and now basically you can run it, and we'll add this here. So we'll say x direction, y direction. Make sure you have everything that's y is lined up together and everything that is x is lined up together. Okay, so now what's going to happen is if we run this, we will kind of get, oh, something wrong here. In definition of constraints, oh, got a typo there. Servo position. Okay. Now what we're going to do is we're going to run it, and we're going to look at the serial monitor to actually tune it. And so we can basically have two methods to tune this thing here. And mine is not running. Do I not have it plugged in? I don't. I programmed the wrong device. Okay. Oh, the other wrong device too. I have like too many things plugged in here. That's what you get for having 100 wires on your desk. Okay. Now I got it right. So let's. There we go. Okay, so now what we're going to do is we're going to tune this guy based on the output from our serial monitor. Okay. Oh, let me change the baud rate to 9600. Okay, so you can see a couple things. So right now I'm not touching the sensor, and you can see that the Y input is at like around 508, 507, whereas the X-axis input is like around 520. So that's the first thing I want to change. I want to make sure I have those centered, and you'll do this according to yours. So X input center, we're at about like, we'll say 520. You can see it fluctuates quite a bit. We can do some averaging to clean it up if we want. We'll go 508. Okay. And so now I'm going to test it. Okay, so I'm testing mine, and I'm looking at the way it moves. And so the next thing I want to do is tune these, right? And so right now, if you look at mine, it's actually not centered, right? I don't know if you can see it. Okay, it's pretty off-centered. And specifically, the one that's off-center is, let's see, looks like it's my y-axis. So I'm going to move it until it gets centered. And so it looks like this is right about centered. This is 118. So then what I want to do is, I want to go in here and say, okay, the center point for my y-axis is 118. Okay? And now we're pretty close. Now my y-axis looks good. My x-axis is also off a little bit. So let me straighten that guy out. So we're at about 72. So I'm going to change my X servo center to be about, what did I say it was, 72? 71 maybe? So I'm going to change that to be 71. And let's run it again. Alright, and that's pretty good. Maybe I went a little too far, so I'm going to go back the other way just a little bit. So now we're at like, maybe like 82. So I'll change that to be 82. And then my actual like axes are switched. So like my y-axis and my x-axis are switched. And so I think probably the best way to handle that would have been before we started tweaking these things. But we can switch these pins. So we'll just switch these, so A1 and A0, and then I'll have to kind of switch these center values to account for that. And so because I switched those pins, I need to also now switch those centers. So the Y input center is now like 526. The X input center is now 512. Okay? And so if you decided, oh, you know what, my one direction is off, you could change this to positive or negative. I'm actually going to look at this one. So I'm going to turn it the right way. So let's see. So actually my X direction is inverted now. So I'm going to switch that back. And we're good. And so once you have it tuned, you also might want to adjust, you know, this angle here. So our max offset, you might want to take that down to like 15 or even 10. Just so that, you know, we have a little bit more finer control over our mazes. So as you start solving your maze and trying to do it, this is where you'll tweak it further to decide, you know, what actual range of motion do you want there. Okay, and so now we've got our control, we've got some finer control here, and we implement this function down here, and we use it here, but because we set up our kind of constants or our variables here, we can tune it up here at the top, so we can get it kind of exactly how we want it.